And we're on to Unit 7. Unit 7 is division in decimals, and our first module and lesson is going to bring us into partial quotients. Partial quotients are very similar to partial products. However, a quotient has to do with a division problem. So you're going to learn a neat strategy that is very efficient and effective, especially if division is not your favorite of all the different operations. Go ahead and date and label your title in your math journal, Partial Quotients. You'll find the date on the board. The partial quotient strategy is very similar to partial products, where you're finding parts of the answer and putting them all together to get your full answer. Now let's get a story problem ready for this. Maya loves going to the scrapbooking store to buy stickers for her collection. All the stickers in the store are on rolls hanging on the wall. The rolls have different numbers of stickers in each segment, based on the size of the sticker. And customers pay for the number of segments they purchase. Maya bought 36 stickers from a roll that had 6 stickers in each segment. How many segments did she buy? So if Maya bought 36 stickers from a roll that had 6 stickers in each segment, and you want to know how many segments she had, what's the division problem? Write it down. Excellent. If you said 36 divided by 6, you are right. So now you're probably wondering, what does this have to do with partial quotients? Well, let's get there. Let's start with an array, like this one. Draw a square. The inside, the area, is 36. One side is 6. What can I multiply by 6 to get 36? You've got it, 6. So on the other side of your area model or your array, you're going to write 6. Copy these notes down in your math journal. It's also important to express what your area model or your array shows. 36 divided by 6 equals 6. The expression is equally important. Now copy this problem down. I'm going to read you a story problem that goes with it to kind of help make it more realistic in real life. Maya bought 360 stickers from another roll that had 6 stickers in each segment. How many segments did she buy? Our expression is 360 divided by 6. So if you notice, since Maya has 360 stickers, that's what goes in the inside of her area model or her array. The outside is one of the segments, so 6. 6 times what number is 360? Think of your basic facts. 360 is 36 tens. What number times 6 gets you to 36? You've got it, 60. Well, let me go back. 6 tens, which is 60. So 6 times 6 tens is 360, or 360 divided by 6 is 60. Don't forget to add this to your notes. I'd like you to take a look and examine the 2 problems you've done so far. We're going to do one more that's relatively easy, and then we're going to dive into these partial quotients. I'd just like you to analyze your work first. Just take a look. Do you understand what we're doing? Do you have a question? If you have a question, now would be a good time to come and see me. Okay, here's another problem. Maya bought 30 stickers from another roll that had 6 stickers in each segment. How many segments did she buy this time? Your expression is 30 divided by 6. Let's make an array or an area model to express this. So remember, the center of the area model is going to be 30 because that's like my area. That's what I have. 6 times some number equals 30. What is that? If you said 5, high five. I knew you can do it. Make sure you write your expression just like the one listed here. Okay, now we're going to do some partial quotients. It's important for you to understand how to use the area model or an array to divide before I start showing you how we can break it up and how it really relates to division. You're actually going to be surprised because you have already done this, but I don't know if you've thought of it as its division before. Okay, if there are 390 stickers on a roll and there are 6 stickers in each segment, how many segments are there? Record this expression down. 390, which represents the stickers. On a roll, there's 6 stickers in each segment, so divide it by 6. Then I want you to draw an array. I already know what you might be thinking. You might be thinking, Mrs. Metalis, I don't know what number times 6 is going to get me 39. That's not even possible. 39 tens, how am I going to make 39 tens? It's actually pretty easy. Watch this. First, make sure you draw your array. If you haven't done so already, pause the video to draw it. We know for certain that we're dividing by 6, or we have to multiply 6 times some number to get us 390. So go ahead and label the one side. Okay, check this out. I have broken up 2 different numbers. These are technically partial products because they're on the inside of my area model. However, I'm going to find the partial quotients, which are going to be listed above. Actually, let me rephrase that. You're going to find them with me. Do you see how I broke 390 up into 360 and 30? Well, the fun part about problem strings is we've already done the work to find what 6 times a number is, or other factor is, to get 360, as well as 6 times some factor gets us 30. So putting those 2 partial quotients together is going to give us our answer. As we know, 6 times 60, or 6 times 6 tens, gives us 360, and 6 times 5 gets us 30. Does this make sense? I think you're getting it. Let's record those expressions down to make sure that we can show our work appropriately. What we really did was 360 divided by 6 and 30 divided by 6. If I take 390 divided by 6, I get 65 by adding those 2 partial quotients. Make sure you have your expression written. Another way to represent this problem is by writing numerical expressions. So 360 divided by 6 plus 30 divided by 6 is 65. Same answer, the work just looks a little bit different. Make sure you have both ways in your math journal because it's important for you to use your notes in the future. Okay, let's try one more. Now, there are 330 stickers on a roll, and there are 6 stickers in each segment. How many segments are there? Go ahead and write an array or draw an array or area model to represent this problem. Okay, well, when tackling any problem, it's nice to use information we already know. And we've solved quite a bit of problems, but we haven't solved anything close to 330, except for 360. So, do you think we can use 360 and somehow break that up to help us get the quotient? We sure can. Let's try it. Divide your array up. Make sure that you're listing with a bracket at the top 360 because I need to know that the whole is worth 360. Now, this small section here on the right, the area there is 30, and I know that 6 times 5 is 30, so I've drawn that in. Does this make sense? Okay, now ultimately, I need to divide 330 by 6, not 360. So I'm not going to count that last section. I know that 330 plus 30 is 360. And I've crossed out or shaded the area in with 30, where the 5 is represented, because I only want to know what is left. And if I know that 360 divided by 6 is 60, and I'm not going to use that last section that represents 30, then all that's left is 50. So This picture should help you see what's been done. Now, this is just a little complex way of thinking, but you can still do this. It would definitely work for you. There's one other way, and I'm going to show that to you. But I'd like for you to record this expression and this work, because this might be the way your mind works. Remember, we all think a little different. 360 divided by 6 minus 30 divided by 6 equals 330 divided by 6, which is 55. These are still partial quotients. Now let's try it this way. Draw the same size array. Let's break 330 up a little differently though. Instead of taking what we already know, let's take 330 and let's break it into smaller pieces. I think this is going to be more up your alley. If there's anything that's been discussed in notes today that seems a little confusing or you're not quite sure about, please make sure to come see me. That's what I'm here for. Okay, so I know that 330 makes up 330. So I've divided my array to look this way. I already know that 6 times 5 is 30, so that would mean that 6 times 5 tens, or 50, is 300. These are my partial quotients. So I'm going to add these together to get my final quotient, which is 55. So make sure you're writing an expression. These numerical expressions are a great way to show your work, but the picture or the array or area model, what have you, is very important as well. Are you ready to tackle some of these partial quotients on your own? Yes, you are.